In Chapter 11, we're going to focus on managing knowledge and something that we've been hearing about quite a bit as of late: artificial intelligence. Here we take a look at the role of knowledge today, particularly in the United States economy. Can you think about examples of knowledge and information sectors? So, for instance, finance, publishing, etc. Here we look at and start by answering the question: what is knowledge as it pertains to an organization? Can you ultimately distinguish between data, information, knowledge, and wisdom? Why is it important to define and describe knowledge? Think about examples. So, for an electric appliances firm, knowing how to make the most efficient and cheapest air conditioner. Here we emphasize the value of knowledge to the overall organization. We want to think about and understand the value, for instance, of a skilled labor force. That value results from the knowledge employees have to do their jobs efficiently and effectively. This knowledge in the heads of employees is extremely hard to replace. Here we also introduce the concept of organizational learning, which describes a process of gathering, creating, and applying that knowledge. Most might be surprised that organizations learn, and others will provide many examples of organizations which refuse to learn anything. In organizational learning, knowledge becomes the driver of new behavior, decision making, new products and services, new business processes. This might be seen also as organizations sensing and responding to their environment. Here we look at the term knowledge management, and we describe the process from acquiring knowledge to applying it as a value chain, and following from here, we'll detail each stage. Each stage of the chain adds more value to the raw data and information. Can you differentiate between the stages and ultimately how each stage could incorporate more value? So, for example, how does knowledge, once it is stored, incorporate more value than the previous stage? Knowledge that is being acquired. We look at the first and second stages of the knowledge value chain: knowledge acquisition and knowledge storage. It describes the different ways in which knowledge can be acquired, as well as describing the ways in which knowledge is stored. Here we also note the importance of management in creating and maintaining repositories of knowledge. So, for example, we might think of a medical practice and think of the type of knowledge they would need and how it should be stored. So, specifically, medical records of patients. We look at the third stage of knowledge, of the knowledge value chain: And we think about ways that knowledge can be disseminated within the organization. Can you think about examples of how you received knowledge from a job that you've had or a university or college that you've attended? What type of knowledge was transferred and what means were used? Were these methods of dissemination adequate? Or do they see more, or could there be more effective ways to disseminate that same information? How can a company or its employees have, quote unquote, too much information? We also look at the last stage of the knowledge value chain, knowledge application. We emphasize the need to see and evaluate knowledge in terms of organizational capital and return on investment. Knowledge management today involves both information systems activities and a host of enabling management and organizational activities. So, our graphic details the stages of the knowledge management value chain, separating the information systems activities from those management or organizational activities involved at each stage. It also describes two other very important requirements for the value chain: the initial data and information acquisition that forms the basis for creating knowledge, and feedback from the knowledge application stage that can result in new opportunities for data and knowledge creation. This slide discusses the new types of organizational roles that managers can develop in order to facilitate the knowledge value chain. Why might a chief knowledge officer, a senior executive position, be valuable to a company? Can you think of why a CKO or other similar type position may or may not be important to the various stages of the value chain? So, data acquisition, knowledge creation, storage, dissemination, and application, and most certainly feedback. We look at three main categories of information systems used to manage knowledge. These categories are different in terms of the constituencies in which they serve, the purpose for which they are used, and ultimately what they emphasize. Three major categories, and each can be broken down further into more specialized types of knowledge management systems. This graphic illustrates the three major types of knowledge management systems, giving the purpose of the system and examples of the type of system. How might you categorize a system that catalogs and stores past advertising campaigns? What about software that helps a research biologist input and analyze lab findings? And so here we turn to AI. The grand vision of AI is very different from the reality of AI. We want to point out that artificial intelligence is not the same as human intelligence. While there are many tasks currently performed by humans that can be performed by machines, and at times much faster, so faster or more comprehensive than humans, human intelligence is much more generalized and powerful in many respects. Google's search engine does something humans cannot do: search several billion websites in response to a query in just milliseconds. Humans, however, know what to search for. There are self-driving cars, but they don't know where to drive unless directed by a human being. The human brain contains an estimated 100 billion neural cells, each with over 10,000 synapse connections to other cells. It operates on 7 watts of energy. The entire body uses 25 watts. Currently, scientists do not understand how the brain works at the microbiological or neural level. There are no computing systems in the foreseeable future that will come close to this level of computing power. IBM's Watson AI system used 200,000 watts of electricity when playing Jeopardy! So, in other words, at least here within the textbook, the author and many other experts dispel the popular ideas about AI or robots taking over the world. All of the techniques are useful tools, but not replacements, at least just yet, for human intelligence. They generally amplify human intelligence. Here are major types of AI. Each type will be discussed more in the following slides. Looking at expert systems, one type of intelligent technique. Why do you think expert systems are best used in highly structured decision-making situations? Can you provide an example of a decision that could not be solved by an expert system? Choice of music, potential spouses or mates, new product decisions, or designing a new marketing campaign might be good examples of poorly structured decision situations. This slide also describes how expert systems work. Their key elements are their knowledge base and their inference engine. Can you demonstrate an understanding of the difference between forward chaining and backward chaining? For example, given a hypothesized expert system to determine what to make for dinner, what would an inference engine with forward chaining begin with? Example, is there chicken? Is there beef? Is there broccoli, etc.? What are all the ingredients available and what could be made from them? What would an inference with backward chaining begin with? We are making chicken with broccoli. Do we have the ingredients? This graphic illustrates the use of if-then rules in an expert system. An expert system contains a number of rules to be followed. The rules are interconnected. The number of outcomes is known in advance and is limited. There are multiple paths to the same outcome, and the system can consider multiple rules at a single time. The rules illustrated are for simple credit-granting expert systems. Have you used Netflix or Amazon's recommender systems? How well did the recommender system help you to find other products to buy or movies to watch that in fact were of your liking? This slide discusses neural networks. Can you think whether neural networks could be used in medical diagnoses? How would this work? To some extent, data mining techniques have replaced neural networks in situations requiring pattern recognition. For instance, credit card companies sift through mountains of transaction data to identify which charging patterns are unlikely for each and every charge card customer. This graphic illustrates how a neural network works by using an internal hidden layer of logic that examines existing data and assigning a classification to that set of data. For example, given one or more specific combinations of age, income, purchase history, frequency of purchases, and average purchase size, a neural network might determine that a new credit card purchase was likely to be fraudulent. What are the benefits and drawbacks of using this type of technique? Deep learning networks consist of many layers of neural networks working in a hierarchical fashion to detect patterns. Shown here is an expanded look at layer 1. Other layers have the same structure. And here we look at some of the limitations of neural networks and machine learning. This slide discusses another type of intelligent technique, genetic algorithms. Can you think whether genetic algorithms might be useful in a medical diagnosis? Why or why not? Can you differentiate between the various intelligent techniques discussed this far? Expert systems, neural networks, and genetic algorithms. This graphic illustrates the components of a genetic algorithm. Chromosomes, each with a variety of characteristics that can be compared for overall fitness in a given situation. Can you think of what types of problems genetic algorithms are suited for? This example illustrates an initial population of chromosomes, each representing a different solution. The genetic algorithm uses an iterative process to refine the initial solutions so that the better ones, those with the higher fitness, are more likely to emerge as the best solution. Can you think about your experiences using digital assistants like Siri, Alexa, or Cortana? Can computer vision systems detect an imposter using makeup or a recently grown beard? Or what about when people age and their faces change? Can they be recognized by a computer vision system? Can you recount any experiences you've had with robots in industry or even in your own home? This slide discusses the use of intelligent agents to carry out repetitive tasks for a user or system. Shopping bots are an example of an intelligent agent. As an example of agent-based modeling, Procter & Gamble used agent-based modeling to improve coordination among supply chain members. Siri, Apple's intelligent assistant, is an example of a software program that can assist users in searching for content and answers to questions with a natural language interface. Have you used Siri before? And for what purpose? This graphic illustrates Procter & Gamble's use of intelligent agents in its supply chain network. Given the intelligent agent modeling mimics the behavior of a number of actors in a given situation, what other types of situations might benefit from this type of analysis? Here, intelligent agents are helping P&G shorten the replenishment cycles for products such as a box of Tide. Here we look at the three major kinds of knowledge that can be found in an enterprise and indicate that less formal knowledge may be just as critical as formal knowledge for organizations to store and share. Can you think of other examples of semi structured and unstructured knowledge? Can you think of an example of tactic knowledge that is more important than structured knowledge, such as a report? This slide discusses the purpose and features of enterprise wide content management systems. A first step in building such systems is describing a knowledge object or a document so that it can be found later by users. Companies must decide and implement classification schemes or taxonomies to define categories meaningful to users, and then knowledge objects must be assigned a classification or tagged so that it can be retrieved. Some content management systems specialize in managing digital media storage and classifications. What types of firms may need these digital asset management systems? Specifically, or for example, publishers, advertisers, law firms, broadcasters, entertainment producers, etc. This graphic illustrates the functions of an enterprise content management system. Users interact with the system to both input knowledge, manage it, and distribute it. These management systems can house a wide variety of information types, from formal reports to graphics, as well as bring in external content resources such as news feeds. Enterprise content management systems can include or consist of capabilities for the creation and management of unstructured knowledge. What might be the difficulties in locating expertise in many of these organizations? Here we look at the Learning Management System, or LMS, which enable companies to track and manage employee learning. Can you think of the benefits and drawbacks of using an LMS with centralized reporting? Here we discuss knowledge work systems, and we identify the importance of knowledge workers to the organization and its knowledge creation. How do knowledge workers benefit an organization? Can all companies benefit from knowledge workers, or only design science and or excuse me, or can only design science and engineering firms benefit from knowledge workers? This slide continues the discussion of knowledge work systems, emphasizing the need of knowledge workers to have highly specialized knowledge work systems. Can you describe the reasons that these characteristics are important for a knowledge work system? What other types of information systems would a knowledge worker rely on, if any? Perhaps office systems, productivity systems, or scheduling systems? This graphic illustrates the main components of a knowledge workstation, having the need for both specialized software and hardware, access to external information, and an easy to use interface. What types of external knowledge might be valuable to an engineer, a financial analyst, or a medical researcher? This slide describes types of knowledge work systems, so CAD or CAD systems, virtual reality systems, and augmented reality or AR systems. What is the business value of providing a financial analyst, engineer, or researcher With an improved specialized workstation, can the value of implementing or upgrading work systems be quantified into a monetary value?